Here's a review for the chemical bonding and nomenclature test. The first question talks about the difference between elements, compounds, and mixtures based on their ability to separate them into similar or simpler substances. Starting at the very top, mixtures are made up of two or more compounds, and they can be separated by physical means. A good example of this would be salt water. Compounds are made up of two or more elements, and they must be separated by chemical means, and it is much more difficult to separate. So this would be like CO2 or water itself. And the last one would be elements. They are made up of only one type of element, and they are extremely difficult to separate, and that's made by chemical means only. Next question. We're going to move on down here to talk about different types of mixtures. Are they heterogeneous or homogeneous? And how would we go about separating them? The first one is salt water, which we talked about earlier. Salt water is a homogeneous mixture. It's going to be the same throughout, and what you would do is you would just evaporate the water and the salt would be left behind. Next here we have iron and sulfur. There's a mixture of two different metal compounds. And basically what you do, metal elements, you would take, it's a heterogeneous mixture, and you would just use a magnet to remove the iron from the substance, from the sulfur. Letter B, chalk and table salt. This will be a little more tricky, but still, it's a physical, removed by physical means. It's a heterogeneous mixture. You're basically going to mix the chalk and table salt with water, and then you can take that solution and you're going to filter it through a filter paper. Salt will dissolve because salt is soluble in water and chalk is not, and so chalk would be left behind. Last one would be carbonated water. This is a homogeneous mixture. So you would heat it up, the carbonation would leave the water or evaporate from the water, and the water would be left behind. Next one, number 3, is what is a chemical bond? This is a method by which two or more elements exchange their valence electrons to make compounds. We're going to talk more about that in just a second here. Moving up here to question 4. Why do elements form chemical bonds? Again, refer back to question number 3. They form chemical bonds to perform a lower energy status and to become more stable in their energy states. And the electrons that are involved in the chemical bonding, those would be the valence electrons. What is the difference between an ionic and covalent bond? These are two types of bonds we've talked about in this unit. It's basically depending on their type of electron exchange. Ionic bonds are transferred between two elements, and then covalent bonds are going to be shared between those two elements. Next part of our review here deals with types of bonds, whether you can tell if something is a non-polar covalent, a polar covalent, or an ionically bonded compound. And basically what we're going to do is we're going to do it by calculating the difference in electronegativity. So if you look in your packet, at your notes, you have a chart that looks like this, a periodic table of electronegativities. Obviously, fluorine right here is the most electronegative element at 4.0, and francium down here in the lower left-hand corner is the least electronegative element at 0.07. So the first question has to deal with, nonpolar covalent. Basically, we're looking for anything that is equal to 0.2 or less than. Those electrons would be shared equally. Polar covalent is going to be between 0.2 and 1.7. Those electrons are shared, but they're shared unequally, meaning one element has more pole than the other. And then ionic, last one will be greater than or equal to 1.7. Those valence electrons are transferred. So using that chart, if we look at nitrogen and phosphorus, so nitrogen is right here at 3.0, phosphorus is at 2.1. That is a difference of 0.9, which falls in here under polar covalent, which is why I have it listed as polar covalent. Phosphorus and hydrogen. I'll show you one more example here how to use this periodic table. Here we have hydrogen at 2.1 and phosphorus over here at 2.1. That's a difference of 0. So that would be a non-polar covalently bonded compound. Magnesium and nitrogen, using that same chart, would be a difference greater than 1.7, which makes it an ionic bond. Carbon and sulfur is a non-polar bonded compound, and the last one, calcium and oxygen, would be ionic. Moving on here to naming our binary covalent molecules. So you're going to be given a symbol for a compound and asked to name it. So I have 2 nitrogens and 4 oxygens. That's going to be dinitrogen tetraoxide. Next one, we have 1 silicon and 2 oxygens. Now something to remember here that is important. If the first element only has one. We do not name the first element mono. We do not add a prefix. We just name it the element as normal. So it'd be silicon dioxide. Same thing here with letter C. There's only one nitrogen, so we're not going to say mononitrogen, just say nitrogen. And then there's 3 oxygens, so nitrogen trioxide. Letter D would be triphosphorus pentanitride. Letter E is going to be very similar to what we had in B and C. There's only one nitrogen, so we don't say mono. We just list it as a regular element, nitrogen dioxide. Same thing here for letter F. That'd be sulfur trioxide, carbon monoxide. We don't say monooxide. Since there's 2 O's together, we take out one of the O's and just say monoxide. NH3, H and I are the 2 that you have to remember. NH3 is ammonia, and CH4 is methane. Now the next section, we're going to give you the formula, and you're going to ask to write out the equation. Excuse me. So here we have diarsenic pentaoxide. So the first one is arsenic is going to be AS. Di means 2. Pentaoxide is going to be oxygen with a 5. Selenium is going to be Se, and there's only one of them. And then tetrafluoride, so it's going to be an F with a 4. Carbon disulfide, so it's going to be 1 carbon and a sulfur, and there's 2 sulfurs. Tetraphosphorus, so it would be P4. Decaoxide, which would be O and 10. Dichlorine heptaoxide, so dichlorine would be 2, so I'm going to put chlorine with a little 2. Heptaoxide would be O with a 7. Last one, letter F, would be arsenic. It's going to be AS. Pentabromide, so bromine is Br, and penta would be 5.